Guys, quick video today. So, um, earlier this year, a couple of games had come out, namely Flight Sim 2020 and now Project Wingman. And those two games can actually use TrackIR in lieu of a VR headset. So, kind of wanted to show you guys how I built mine. Had a couple of people asking. But this is pretty much a DIY unit that I 3D printed the base for. Of course, you don't need to 3D print this. You can build this out of anything so long as the LEDs are mounted in the correct position. You're fine. This doesn't have to look like this shape. Um, so a commercial TrackIR unit is about $250, $300, something like that, depending on when you get it. But the unit I'm building, I had most of the tools for, so I think I spent maybe like 20 bucks on. Now, if we were to get this entire thing from scratch, I think you'd probably spend neighborhood of $50 or $60, something like that. That's assuming you had all the tooling you need to actually build the unit itself. Probably the most expensive tool you're gonna be your soldering iron, which I think really nowadays you can get one like cheap for about 10 bucks. This one was rather expensive, but you know I do a lot of soldering, so pretty neat unit. This one goes from like 0 to, well, rather room temperature to like 300 in about 20 seconds flat. It's pretty ridiculous. So the next thing you're gonna need, infrared LEDs. Now these I just picked up off of Amazon. These are a pack of 100 for like 10 bucks, something like that. Now if you can find more powerful ones, do so, but you also need to get different resistors to match that. But these are the ones I used, so I'll give you the spec sheets on what went into mine. These guys are about 1.2 to 1.5 forward voltage, 20 milliamp power consumption. So the easiest way we're going to do this is just to hook this up in series. That way we can use just one resistor in the entire circuit. These are 22 ohm resistors, quarter watt, and minimize some of the wiring hassle. Now you can wire these directly to a USB cable, but I've elected to use micro JSTs. That would be something like this. That way I can actually unplug it from my headset if I needed like just to power down the unit or whatever. But this is an optional thing. You can always solder the power cable directly to the unit. That doesn't matter. But I'll be using this method. So with the micro JST cables, I actually have a good length of cable around here to almost complete the entire circuit without needing any additional wiring. But I do have some random pieces of cable from the other two, wow, if I can speak, from the other two TrackIR units I've tried building. One I used without a resistor. That one nearly caught fire, so don't do that. And then one failed unit from when I was, practicing getting my soldering skills on point. With wires this small, it's fairly easy to solder, but it's also very, very easy to screw up. So the first thing you're gonna need to do is get your LEDs. You need to grind down the lenses so they're flat like this. You can do this using a hand tool. I had a Dremel tool with a grinding attachment on it, so I just ground that off, polished it up. You do need to polish it up a little bit just so it allows a little bit more of that infrared light to transfer through. If not, you get a really weak glow on this thing. Now there's not going to be a whole lot of insulation on this particular unit. I know that's gonna like freak out a couple of people, but towards the end what I'm going to do is I'm going to fill this entire channel up with hot glue, and that's going to be the insulation. So basically we're just going to bend it into shape and the geometry is going to hold it. Gotta make sure my phone's still recording. Yes, I am recording my phone because my main camera is dead, unfortunately. Discontinued camera. They don't want to make the batteries for it, I don't think. Let's see. Go ahead and pull some of that insulation off the cable. Pull out one of our 22 ohm resistors. I don't believe these are like sensitive to which direction you put them in, so go ahead and cut that close. Measure 15 bajillion times, cut once, still get it wrong. Yeah, these can be a little bit shorter. Realistically, you don't have to cable manage too terribly much on this thing, but you know, I did that last time, so this time around I think I want to do a little bit better job on it, but it doesn't really matter. Okay, so I'm gonna go ahead and grab this, shove that in here. Come on. Oh yeah, the other thing is that you have to somehow do this while still letting the camera see what the heck I'm doing. No? Let's really get some on that. There we go. Then we can cut this off. Do a little bit on that. Okay, so this is going to go on the positive end of this. See, that's the thing with solid cord wiring of any sort. Is that I find it very difficult to get solder on these things. Whew, okay, close, very close. Almost cut it too short. Okay, so next one. So we're gonna go negative to positive on these guys. So that means I need to bend this guy like 120 degrees this direction. Now remember which side's the positive side. Because nothing sucks more than getting all this stuff wired up and then realizing that you had the wrong end of the terminal. You know what I needed? My little tin of flux. I don't know where the heck that thing went. You know what? I'm gonna grab my hot glue gun and glue like this half of it in place so it just stops flopping around. And I'm just gonna hot glue this thing in place. So I can't find my lighter, so this will have to do. Just to get the heat shrink down. I almost have it slightly too short. No, perfect. Whew, okay, so that measured out just about perfect there. That was close. What I need to do next is get the third diode on it. Bend this over a little bit so it hugs that wall a little bit more. That should be negative to positive. Now luckily this particular diode was just long enough for me to reach it. Actually, it would have been long enough for me to reach it had I not snipped off the end, but let's put a slight bend in that just so it kind of faces forward. Needs a bit more. Let's see, I just need to raise this out of the plastic a little bit just so I don't melt the plastic. I'll put that somewhere. Thing of heat shrink. Nope, where'd my... And throw some hot glue onto it. And done. Just like that in about 20 minutes. So the way this works is that this is just a piece of plastic that I got off of some packaging. You know, this sort of thing. Any piece of clear plastic will do as long as it's, you know, sturdy enough for you to really use it long term. And then the only other thing you'll need is a black Sharpie marker. So what we're going to do is just take this and color it black. The whole idea here is to filter out all the visible light. So you want to do one direction on one side, let that dry. Since Sharpie is an alcohol-based marker, it doesn't like going over itself because it'll just re-wet itself and then just be moving it around. So what I do is I'll go one side in one direction and then the next side perpendicular to it. Now, if you held this up against a light, you can still see through it somewhat, but you want to get this as dark as you possibly can. Because the idea now is that, let me tilt this upwards, is that I can put this over the camera lens, but infrared light will still make it through. Now that's the key here. The camera that you're using for this has to be able to pick up infrared light. Now most cheap webcams don't have an IR filter on it, but a lot of them do. Now I find that the cheaper the camera, like the cheapo Chinese ones, they skimp out on the IR filter too. Now Logitech, on the other hand, some of their higher end ones don't. Like got a buddy of mine, Eisen, he's got like a C900 series camera and that doesn't work. You can barely see the infrared on it. But the other alternative is that a lot of people are using like PlayStation Eye toys for it and then removing the IR filters from those. Of course, it's late 2020. I just dated the video right there, but the world's kind of on a webcam shortage, so good luck. Have fun with that one. Okay, so I've got this thing powered on, and then I'm going to show you the piece of software I'm using and how to mount this thing. So the way I've done this is that piece of plastic that we've Sharpied, I just simply taped it to the front part of my webcam. And then for the software, I just took basically the default settings of this OpenTrack 1.1 and FreeTrack 2.0. Then the filter, I think the Accelerator was the only one that works for anything. This one's, as you can see, my Project Wingman profile. Of course, typically one profile works for multiple things, except Wingman I had to invert pitch because for some reason I couldn't do it through the game. Let me show you some of my settings here, that way you can at least copy these and have somewhere to start. So the one other thing you'll need is that your webcam, you need to be able to, oh, it's down here. You need to be able to manually control these options here. So this is what I have all mine set to. The exposure is probably the most important because you need to open that aperture up enough that you can detect your IR filter, or your IR LEDs. But the other major thing is your FPS. Now, unfortunately, my camera caps out at 30 FPS, so when you're moving your head, there's a slight delay to it. If you can find one that's like 30 FPS and has no IR filter on it, or can modify one to remove the IR filter, all the better for you. But that's what I had to set my camera to get it to work. But since at this point it's pretty much just a light sensor and not a high resolution camera, the resolution of the camera doesn't really matter. Your field of view kind of is a bit more important, and along with the frame rate you can push. So let's close that. Let me show you my curves. So this is what I'm running for curvature. If I can get my camera to focus. Then you can pause the video to have a look at these. But yeah, that's pretty much my settings. Download's over, give it a shot, and then from there you just have to really play around with it and fine-tune it for yourself. So we're just going to jump into a simulator and fly around for a little bit and just kind of demonstrate that this home-built TrackIR thing does work. And it works pretty well for something I've only spent maybe $20, $30 on.
Altitude. Pull up.
Oof. My FPS just kind of disappeared on me. That's the one thing with DCS, is that it doesn't like playing at this large of a resolution. Oh, there's the airport.
Bingo.
Well, let's put this thing down. Got like a little under 2,000.
Altitude.
You get that glide slope right. Now that'll do. Nope. Then we just hold it here until 100 knots. And then gradually apply brakes. And hey, we're in one piece. Nothing worse for wear. Of course, we still look around.